Okay, now let's go ahead and take a look at what all this means. It's a lot of terms and it's hard to see just by me talking through what these are, what those conditions and assumptions are. But let's go ahead and look at some data. Again, if you want to come along, just watch. You can download the data on your sheet. I've given you the links to the data. Let's go ahead and get there. Okay, and so you have a link to it'll take you to StatCrunch. If you click it and you have StatCrunch, you can get the data here. Or you have a link to Google data, the data on Google Sheets. And you would copy, you want to make sure you copy, let's get rid of that. You want to copy and paste that into, let's get there. Copy and paste that into the ArtistStat. And so when you get to the ArtistStat, of course, you're going to enter your own data. I copied the X, and again, you would go ahead and copy the Y value from this one too. Get off of that, there you go. And again, it's a copy paste, a little bit more work than the StatCrunch link, but you still get the data in. And you're going to linear regression as it says on the instructions for ArtistStat. And so you'd submit the data here. And let's take a look at what we're going to do. So in StatCrunch 2, so you end up in StatCrunch, you have those instructions there. What we want to do is go to Stat, Regression, Simple Linear, and then you're going to click on Fitted Line down here, Fitted Line Plot. And then you want a histogram of the residuals, because remember those conditions that we had about making sure there's a normal distribution, that the residuals are normally distributed. And so we would go ahead and do that, and then the residuals with the X values you want to see. There we go. And so, I got to select the columns up here. You have multiple choice and response. If there's a relationship between on the final exam, the multiple choice part and the free response, is there a relationship to the two parts? You would go ahead and calculate that, and notice here you end up with, first again, all the regression data, correlation coefficient. What we're going to end up analyzing here is this column here of the parameters. We're going to want to go ahead and look at that. But again, we're going through the data to look at how we would get to those conditions here. And so again, here is the histogram of the residuals. These are our observed values compared to the predicted ones, and pretty normal, and I like how it draws the curve in there. And then you can see this is the scatter plot of the residuals, and so you can see with the X and the residuals, you can see that it's kind of random, which is what we were looking for back here when we wanted to test that to make sure all the conditions. See, it's kind of random over here, and that we have normal distributions of the residuals. And so once we have that, then we can go ahead and run the tests. And as you take a look at the setup here, here's the null hypothesis. What we're testing to see is if the slope equals 0. If not, it does not equal 0 or greater than 0, right? Or less than 0. It has to do with a positive correlation, whether it's positive or negative, right? When your slope is positive, it's in a positive association or correlation. And so we want to see if there's evidence of that. We're going to run a linear regression t-test for the slope, and then we have all of these things here. We just check these, right? The original data is looks like it's linear. Let's go back real quick. So even here, as we look at the fitted line, it has some linear relationship. Again, looking at ArtistStat, you can see that also here. You can see here we have that linear relationship. Look at the regression line here. You can also, again, show the residual plot, which is what we're looking for here. Okay, kind of looking to see it. So those are some of the things that you want to, where's the other? Oh, right here. We need to do fitted residual analysis. There's the residual plot there also. So you can go ahead and see And then there's the histogram. So ArtistStat, you have that idea, so that now we can actually run this hypothesis test that we're looking at. Again, just want to make sure you get a chance to see how you do this with technology. Students take it individually, so we assume independence, right? Everyone's doing this final exam on their own. We have the histograms as unimodal or mostly symmetric, so we're good there. Residual plot looks random, right? There's no kind of pattern within that situation. Looking at our test here, it's not a random sample, but again, we hope it's representative of the student population, so we can say that it's that's the key, that it's representative. And then you get your t values here, right? You get your here and your p value. And so with that number there, let's get back to that test. There's the p-value so small that it's less than 0, so we're saying that the slope is not equal to 0, right? That we have some positive, we have some relationship, or there is a positive correlation with that data. And that's how we're going to end up, that's how we end up running the test, looking at that. And then, of course, we had the conclusion there with that. And then you know how to end this last section, there's some questions on making predictions. And then we have one other thing. What happens when you have a correlate? What happens if you have no correlation? Important here. Is there evidence of a relationship? If there is, right, your p-value is less than alpha, then you just use the equation like we did in the last sections. If the p-value is greater than alpha, this is, or your conditions fail, right? We can't use a regression. The best estimate for any x value is just going to be the sample mean for the y. That's important to recognize there. Again, if you have no association, all we can do to make a prediction is use the sample mean, use the average, use the mean as your prediction.